Hello everyone, welcome to my channel Aptitude Club. Hope all of you are doing well. This is a question on set theory and set maximization, minimization. This was a previous ZAT question, and we'll be discussing this question again in two different ways. Now, the reason I have taken this up because when we read set theory, a lot of times we think about Venn diagrams, and a lot of questions are solved using Venn diagrams also. But there's something called as line diagrams, which a lot of people are sometimes not familiar with. So, line diagrams are basically used to solve set maximization and minimization problems easily. And if you just know the technique, these kind of questions or even complicated questions like this becomes very easy to approach and solve. We also use Venn diagrams to solve, but this is a different way of like putting it in diagram. So I'll again solve it in two ways. First, I'll take you through what line diagram is and how do I use the line diagram in this case, and then we'll discuss the shortcut to solve this question. So again, all of you watching this, do pause at this moment and try this question yourself first. Not very difficult. I hope a lot of you can solve this. And if not, you can watch the explanation anyways. But do try it first by pausing the video at this moment. So what is given? Let us first read the question. 70% of the students who joined XLRI last year play football. 75% play cricket, 80% play basketball, and 85% play carom. So there are four different sports played by the people who have joined XLRI this year, and the minimum percentage of students who play all four games. Of course, we cannot like decide the exact number of students who play all four games. The data is not sufficient. Okay, it's talking about individual sports, so we don't have sufficient data to exactly say how many people play all the four sports. Now, think of it in a very standard way that if I'm looking at the total population on XLRI at XLRI, so there would be people who are playing just exactly one sport. People would be playing exactly two sports. People would be playing exactly three sports, and people would be playing exactly four sports. And then there would be people who don't play any sport at all. So these are basic five categories into which I can divide all the candidates. But we don't have enough information in the question to exactly know what people play, what number of sports exactly. So in that case, obviously the question is going to ask you minimize or maximize. So we'll use something called as line diagram. So I'll do it in this way. Let the total students, let us say is 100x, and I'll use something called as line diagram. Now what is this line diagram? Think of it in this way. Suppose I represent the entire population like this, and here if I take cricket, how many people play cricket? Now 75x. Now let's start with football. Football दिया है, तो let us start with football. So this total thing is 100x. So how many people like football? Now 70x. So 70x would be somewhere here. These many people like football. Now if I have to maximize the number of people who like football and cricket, so I have two choices. If I consider cricket from this side, the number of people liking cricket is 75x. So 75x would be somewhere here, and all these people who like football, now they also like cricket. So cricket intersection football I can say is 70x, and this is the maximum case. इससे तो ज़्यादा हो नहीं सकता. Like if I want to maximize the number of people who play both football and cricket, so it can be 70x maximum. But if you want to minimize, what you do is same thing. So football is 70x somewhere here, and cricket is 75x. I'll take it from the opposite end, and it will be somewhere here. So these 30x people, they do not play not football, and these 25x people, they are not cricket. So whatever is left in between, how much will be this? Total is 100x. I'll exclude 30x because they don't play football. I'll exclude 25x because they don't play cricket. So I'm left with 30, 25, 55, 45x. So remaining 45x people, that's the minimum that I can get. So minimum people who play both the sports, cricket and football, is 45, whereas maximum is 70. So this tells you a very important thing, that if you want to minimize, you take both the parameters from the same side, and if you want to minimize, you take it from the opposite ends, just like we did it here. Whereas if you want to maximize, you will take it from the same end, so that the overlap is maximum. If you want to minimize, you take it from opposite ends, so that they overlap as minimum as possible. Lesser the overlap, lesser the intersection, lesser the number of people who play both the sports. So that's the like a rationale of using line diagrams. But here we don't have two parameters, rather we have four sports. So how do I approach that question? So step one is done. Cricket and football minimum is 45x. So I'll minimize every time. So next time what I'll do is step two. On one side I'll take cricket and football, and I see, okay, that is 45x. So that means 55x people, they do not play. And similarly I'll intersect with another sport, that is basketball. So basketball is like 80x. 80x would be somewhere here. So these 20x people, they do not play basketball. So from 45 I'll exclude 20. So this thing now becomes 45x minus 20x. I get 25x. So these 25x people, they play cricket, football and basketball as well. Now I will intersect this with the number of people who play carom. So cricket, football and basketball is 25x. So the remaining 75x people, they do not play like all the three sports. 85% people play carom. 85x is carom. So 85x is somewhere here. So the remaining 15x people, they don't play carom. So what is this? The number of people, 25x minus 15x, which is 10x. These many people definitely play carom, football, cricket and basketball. Hence I'll get a minimum number of people is 10x or 10%. So what I'm basically doing is, I started with two sports, minimize their intersection. That intersection again intersected with another sport. Then I got three sports intersection. Then I'll take it with the next sport, and gradually I'll do it like that. So we had a question like this, six types of foods were there. Same previous that question it was there. The logic is similar, just you need to solve two or more steps, but the process is exactly the same. This is called as line diagram, and you can use this to solve such kind of questions. Just keep it in mind that whenever you have to minimize, you take it from opposite ends, and whenever you have to maximize, you take it from the same end. Now there's an easy way to solve this also, shortcut. Let me tell you the shortcut also. So total number of people is 100x. Now football, 70x are playing. Then cricket, 75x. Basketball is 80x, and carom is 85x. What is your objective? That you have to find people who play all four sports first, who can play all four sports, and then you will have to minimize this. Our objective is this. Now if 70x people play football, I can say 30x people, they definitely don't play football. Now these 30x people who do not play football, can they play all four games now? Definitely not. If they are not playing football, how can they play all four sports? So definitely एक sport तो खेल ही नहीं रहे हैं, guaranteed. Similarly, if 75x people are playing cricket, that means 25x people are not playing cricket. Similarly, 20x people are not playing badminton, and 15x people are not playing carom. So if I exclude all of them, 100x minus all this, 30x plus 25x, I'm excluding people who at least do not play one sport. So how much am I getting? 100x minus, this is 40, 20, 60, 30, 90x, 10x. Now this has to be the minimum. Minimum number who play all four sports. Now this is the shortcut, hence 10%. I straight away start subtracting 30x football. If they are not playing, straight away subtract them from the total population, because they can never be the people who play all four sports. So just exclude them. Similarly, exclude people who do not play cricket. So you arrive at the minimum. Now some people still can think, how is it minimum? How would I know that if it is minimum? Now think of a case like this. If I have subtracted a person here, one person who doesn't play football, may happen that the same person also doesn't play cricket. Can be the same person. Let us say person P1. You excluded person P1 in football, and the same person doesn't play cricket also, but you have excluded the person twice. You should have excluded once. But if one person does not play multiple sports, so your exclusion is reduced. In this case, it's like I have excluded 90 people. But what if from these 90 people, there are people who do not play multiple sports? So you don't exclude 90 people now, you will exclude lesser people. So if I exclude lesser people, then this difference won't be minimum. If I exclude more people, then this difference will be minimum. So I am straight away subtracting 30, 25, 20, 15, taking the case that there is no intersection between them, no common person. So that gives me the maximum exclusion, so minimum number of people who can play all four sports. Hope this makes sense. A little like tricky this question to think on, but not difficult, and I explained you two different methods to solve this. Hope all of you understood the explanation. That is it from my end for this video. If you have watched it this far, do subscribe to my channel. I'll regularly come up with more such videos. In every video, I'll discuss one question in the QA booster series. So one video, one question, and it will enhance your concept or help you think maybe in a different way on the questions. If you are new, do explore my channel and watch the previous videos. And if you like the content, do not forget to subscribe. And we'll meet again very soon in yet another video. Till then, keep solving, keep studying, and thanks for watching the video. Bye bye.